Hi, fourth graders. Today we're going to talk about force, energy, and motion. So let's review. What is motion? Motion describes the object's position over time. So if you think about our car and if we're leaving our house, over time we go to a new position or location. That is motion. So let's practice. For our line graph today, we have a data chart that goes with it. And our line graph focuses on the distance that object can go in seconds. So according to our data plot, we have in 1 second, an object went 1 foot. In 6 seconds, the object went 5 feet. And then in 12 seconds, the object went 10 feet. And if you notice, we went from 1 second, 1 foot, 5 seconds, 5 feet, and then all the way up to 12 seconds, 10 feet. And then we even went to 17 seconds, 15 feet. So did our line graph go increasing, decreasing, or staying the same? So speed. Speed describes how fast an object is moving. Speed is a measure of motion, and speed is either increasing, decreasing, or remaining the same. So is the speed in these examples increasing, decreasing, or staying the same? Okay, now that you've had time to answer your question, let's look at each graph. So for the first one in the top left corner, it starts at 0 and it goes up. So that means that if it starts at 0 from the left and it's going up, then it's increasing. Now for our line graph in the center, it's starting up really high on a really high number, but as the graph goes moving left to right, it's going down, so it's decreasing. And then we have a graph with a straight line. That means that the speed is never changing and it's staying the same. So force. Force causes an object to move. A push or a pull that causes an object to move, stop, or change speed or direction. So go ahead, find something on your desk or at your home and push it really softly. Did the object move? Now push the object just a little harder. What happened? Now pull the object closer to you. Did it move? Gravity is the force that pulls down. Let's identify the direction of the object's motion. So up is relates to why do we apply force for an object to go up? Maybe we were hitting a volleyball or we were throwing an egg and we wanted it to go up, or throwing a pancake or anything. So going down, we apply force to an object and cause force to push the object down. So maybe if you're playing basketball, then you're pushing the ball down when you're dribbling. You want it to bounce, and then it'll come up because the floor and the basketball met, and it goes up, and then apply force. Then we have forward. Forward is now apply force to an object and cause the force to push it forward. Anytime that we push something, then it's going to go forward. And then we have backwards, and that's when we always, if we're pulling something or we're pushing it backwards. So mass, what object is heavier? What object would I have to apply more force to get them moving at the same speed? Would I have to apply more force to a soccer ball or a bowling ball? So we're focusing on which object is heavier, and a bowling ball can be around 8 to 14 pounds, but a soccer ball probably isn't going to be more than a pound at most because you have to kick it, and it will be really hard and really tough to kick a heavy ball. So you would have to apply more force to a bowling ball to get it moving. Okay, so let's review. Does the mass of an object affect the amount of force needed to move it? Yes, it does. The greater the mass, the more mass is needed to move it. So for our baseball, we don't really need that much force, but for a bowling ball, is not going to go far if we hit it with a bat. And then we have this huge ball. It's more effort, and you can see on his face that it's harder to push compared to the small ball, and he's just smiling and it's very easy.